of what the activity is representing. So to achieve all those two steps I spoke before, I will start. I will talk about four things mainly. First, the futures is what we work with. Later on, the context, how we will add semantic information, how we build these primitive events, what are going to be the semantic bricks that will help us building the models, and later on, the three main steps to discover, model, and recognize activities automatically in new data sets. Finally, end up with the results and some conclusions. So first, as I said before, we will split the video into chunks. The idea is, remember we're talking about long-term activities here, so we have big amount of data, long videos. So the idea is to optimize as much as we can, the amount of video we are storing. It needs to be all time useful. So one of the things that we adapt these chunks, the size of these chunks dynamically. We do the breaks of these chunks by understanding the changes in the speed of the person. We are assuming always that we have a person tracker or an object tracker here. So the thing is that this speed is usually noisy, so we use a cascade of Kalman filters to smooth the things a little bit there, and after that we directly threshold the resulting speed. And like that we have some different breaks, and with those breaks we have the chunks. So these chunks we call them as well actions because we are obtaining chunks that can be meaningful in a semantical way. This is we can put labels to these chunks. We hope to have those things. So now we have to abstract information. These actions here are still video, so we need to extract useful information for us. A third thing, and most of the approaches use, is extracting global features. And we will extract only two features here, is the beginning and ending position of the person within the chunk. But the problem with that is that when activity is taken at a very particular location, same location, it's not possible with a global feature to differentiate between two different activities at the same location, as you can see here. Here, because of the camera point of view, it can be confused as the person reading or the person sitting there. So what we do is we add local features to the characterization of this chunk of video. The problem with adding local features is that object tracking is not, my understanding, is not ready enough or is not accurate enough to track, for instance, the hand of the person, the torso, head, and things like that. So what we will do is we will track pixels. We will track pixels, and after that we will process those pixels, trying to obtain these green lines, as you can see here, these green tracklets that are describing the main local dynamics of the movements of the person. As you can see here in this example, the person is at the same location, but it's very easy to see that that the movements are different. So it's describing different actions. So for that we will can do it in four. We will do it in 4 steps. First is the initialization, where we locate 600 current points using the good features to track for OpenCV at the first frame of an action, and we track them using the pyramidal implementation of the also in OpenCV, thanks to the people of OpenCV for that. And we track those points to the end. Here we tried as well SIFT and SURF, but they were not adding too much, and well, the processing time, since I'm not using GPU here, was much lower. So with that, it's okay. As you can see, you have, as a result here in pink, a lot of tracklets. Is it visible? Okay. You can see a lot of tracklets describing the same type of movement. What we are interested in to have is the main movement. This is what we call the local dynamic. And for that, what we will do is here, the step C is clustering. Of course, the thing of clustering is that we needed a network capable of detecting automatically the number of clusters that was strong in the initialization. So what we did is we used Minshift. There's a little bit of the history of Minshift. The important thing here is that it